and welcome to the Math League YouTube channel. The following video was recorded by one of our staff members live at one of our contests.
Hi, I'm Joeli. I'm another one of the interns here at mathleague.org, and I'm going to go over problem number 6 from the target round right now with you all. So let's go ahead and get started. The problem reads, 1 unit square in a 6x6 grid is colored in. Over all choices of unit squares, what is the smallest possible number of rectangles that can be traced along the edges of the grid with edges parallel to those of the grid, which do not contain the colored square? So to start, there are 7 horizontal lines and 7 vertical lines. And to make a rectangle, each unique rectangle is made by picking 2 of the vertical lines and 2 of the horizontal lines. So altogether, we have a total of 7 choose 2 squared possible rectangles. And since 7 choose 2 is 21, then we have 441 unique possible rectangles that can be traced along the edges of this grid. So now what we could try to do some heavy casework, but that'd be pretty difficult considering how many options we have. So we can do something that makes things a little bit easier for us. To illustrate, I'm going to arbitrarily choose one of these squares to be colored in. Let's say it's this one that I just put the star in. So we see that no matter what square is colored in, there's a certain number of horizontal lines above it and a certain number of horizontal lines below it. And there's a certain number of vertical lines to the left of it and a certain number of vertical lines to the right of it. So let's go ahead and say that there are X horizontal lines above our colored in square, which means that there are 7 minus X horizontal lines below our colored in square. And then similarly, we can say that there are Y vertical lines to the left of our colored in square. So there are 7 minus Y vertical lines to the right of our colored in square. So setting it up like this, to create a rectangle that does contain this colored in square, we have to pick one of these X lines, one of these 7 minus X lines, one of these Y lines, and one of these 7 minus Y lines. So altogether, there's going to be X times 7 minus X times Y times 7 minus Y rectangles that do contain the colored in square. We want to find the smallest possible number of rectangles that don't contain the colored in square. So since we know the total number of possible rectangles, we can find the smallest possible number of rectangles that don't contain the colored in square by finding the greatest possible number of rectangles that do contain the colored in square, and then subtracting that number from our total. So we want to maximize this expression here so we can find the greatest possible number of rectangles that do contain the colored in square. And this expression is maximized when out of X and 7 minus X, one of these quantities is 3 and the other is 4. And then out of Y and 7 minus Y, one of these quantities is 3 and the other is 4, which gives us a total product of 3 times 4 times 3 times 4, which comes out to 12 times 12 or 144. So we see that the greatest possible number of rectangles that can be traced along the edges of the grid without which contain the colored in square is 144. So subtracting that from the total number of possible rectangles in the grid, we get 441 minus 144, or 297, as the smallest possible number of rectangles that can be traced along the edges of the grid which do not contain the colored square. That's our solution, and we're done. Thank you.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.